Hello, my name is Rhoda and I will be teaching you about Module 10, Rigid Motion Transformations. So, what is a rigid motion in geometry? Rigid motion is otherwise known as a rigid transformation and occurs when a point or object is moved, but the size and shape remain the same. In rigid motion, you will typically see two shapes that show the transformation. The original shape is called the pre-image, and its points will normally be marked with capital letters. After it's been moved, the transformed image is called the image. The points of the transformed image will be marked with an apostrophe. In order for the movement to be rigid, the pre-image and image must be congruent. Congruent statements are expressed as first triangle is congruent to the second triangle. If you want to keep moving the same image, add more apostrophes to the letters, naming the points after each movement. Translations will be the first type of rigid motion we will go over. A translation is a type of rigid motion that occurs when the shape shifts or slides without changing its orientation, size, or shape. It is a function that moves each point of a geometric figure a fixed distance. A units move in the x direction, and B units move in the y direction. This can be represented symbolically as t parentheses x comma y parentheses equals parentheses x plus a comma y plus b parentheses. We will now do an example of translations. This example wants us to translate triangle ABC such that txy equals x minus 7 and y plus 4 to form the image triangle A apostrophe B apostrophe C apostrophe. This means it wants us to slide the triangle to the left 7 units, and it wants us to slide the triangle up 4 units. To solve this problem, we will be putting these points into this equation. We will start with point A. Point A's coordinates are 1, 2. So we will write it out. It will be 1 minus 7, comma, 2 plus 4. And now we will solve it. 1 minus 7 will equal to negative 6. And 2 plus 4 will equal to 6. Therefore, the new coordinates will be negative 6, 6. Now, we will do the same with coordinates B and C. Coordinate B is placed on coordinates 4, 3. Now, we will write it out as 4 minus 7, comma, 3 plus 4. And we will get negative 3, comma, 7. And point C is placed on 4, 6. So we will write that out. So it will be 4 minus 7, comma, 6 plus 4, which will equal to negative 3 and 10. Now we will place our new coordinates. So negative 6, 6. Negative 3, 7. And negative 3, 10. And we will get triangle A apostrophe, B apostrophe, and C apostrophe. The next transformation is reflections. A reflection over line L is a function that moves each point P to the point Q such that line L is the perpendicular bisector of line PQ. Or it is a geometric figure that is reflected across a line creating a mirror image. That line is called the axis of reflection. We will now be doing an example of reflections. This example states, reflect the pre-image triangle ABC over the line x equals 7. Label the image vertices B, D, and E so that triangle ABC is congruent to triangle DBE. Now we will observe the points of the triangle. Point B is on the line of reflection, so it will stay the same. Now we will observe points A and C. Point C is 2 points away from the line of reflection, so we will count. 1, 2. Now for point A. Point A is 6 points away from the line of reflection, so we will count 6 points. 1, 2, 3, 4, 5, 6. So the triangle will now look like this. Now to label the new image so that this triangle will equal the triangle ABC. B will stay in the same place. So that means when A is flipped, it will have the same letter as D. And when C is flipped, it will have E. We will do another example. This example wants us to reflect the pre-image triangle ABC over the x-axis. Label the image vertices X, Y, Z so that triangle ABC is congruent to triangle XYZ. So for point A, it is 2 units away from the line of reflection. So we'll count 2 units. 1, 2. Point B is also 2 units away from the line of reflection. So we'll also count 2 units. 1, 2. And for point C, it is 5 units away from the line of reflection. So we'll count 5 units. 1, 2, 3, 4, 5. And it will make the triangle. Now, we will need to label it with the point so that it is congruent to ABC. So X will be congruent to A. So this will be X. Y will be congruent to B. So this one will be Y. And C will be congruent to Z. So this point will be Z. Now, reflections will lead us into the next type of transformation that is similar to reflections, which is called reflective symmetry. Reflective symmetry is when a shape or pattern is reflected in a line of symmetry or a mirror line. The reflective shape will be exactly the same as the original, the same distance from the mirror line, and the same size. We will now do a few examples of reflective symmetry. Here are 3 regular polygons. We will write a line so that the pre-image and image of the reflection over the line of symmetry lie directly over each other. So for the triangle, the lines of symmetry would be here, here, and here, because they are symmetrical. For the pentagon, the lines of symmetry would be and for the hexagon, the lines of symmetry would look like. As you notice, all lines meet up to a certain point. Now, Our last type of rigid motion is called a rotation. Rotations occur when an object moves around a certain point. The point in which the object is rotated can be inside the figure or anywhere outside it. The amount of rotation is called the angle of rotation and is measured in degrees. Now, before we do any examples, here is a list of all the ordered pairs you should write down that we will use to solve a problem. Now we will be doing an example. This example wants us to rotate triangle ABC 90 degrees in a clockwise direction about the origin to form triangle DEF. Label the image such that triangle ABC is congruent to triangle DEF. So we will use the ordered pair 90 degrees equals y, comma, negative x, which will turn the point A to 3, comma, 4, point B to 1, comma, 1, and point C to negative 1, comma, 2. Now I will place the new points onto the graph. 3, 4, 1, 1, and negative 1, 2. I will make it into this triangle. This. Now we will have to label the points so that it is congruent to triangle DEF. So A will have the same point as D. So D will be on 3, 4. B is congruent to E. So E will be 1, 1. And finally, C is congruent to F. So F will be negative 1, 2. Now we will do an example that combines all of what you just learned. So this example says, rotate triangle ABC below 90 degrees in a clockwise direction about point B, followed by the translation T defined by T xy equals x plus 1 and y minus 2. And finally, a reflection over x equals 10. Label the resulting triangle A apostrophe B apostrophe C apostrophe such that triangle ABC is congruent to triangle A apostrophe B apostrophe C apostrophe. So first of all, it wants us to rotate triangle ABC 90 degrees clockwise by point B. So points A and C will change except for point B. A and C will make a 90-degree angle. Point A will become 9, 9. And point C will become 12, 6. Now we will write out what the triangle will look like. So this is point A, and this is what point C will look like after the 90-degree clockwise rotation. Now, it wants us to translate the triangle to the right 1 unit and down 2 units. So, point A will become 10, 7. Point B will become 10, 1. And point C will become 13, 4. Now we will graph those new coordinates. So A will be 10, 7, 7, 10. B will be 10, 1. And C will be 13, 4. And now the triangle will look like this. And now, our last step is to reflect the triangle over x equals 10. So since points A and B are already on x equals 10, it is only point C that will move. Point C is 3 units away from x equals 10. So we will count 3 units away. So the new triangle will look like this. Now all that is left to do is label the last triangle with A apostrophe, B apostrophe, and C apostrophe so that it is congruent to triangle ABC. The point A would be the same as A apostrophe. So this would be A apostrophe. Point B would be the same as B apostrophe. And point C will be the same as C apostrophe. Before I end the lesson, here are all the vocabulary words that you can take note of. Thank you for watching, and I hope you learned how to do rigid motion transformations.